A ruthless murder was committed 66 million years ago. The victims were the dinosaurs, rulers of Earth for over 150 million years. For decades, science has blamed a single, spectacular event, a massive asteroid striking the planet. 10 kilometers of rock, traveling faster than a rifle bullet, unleashed energy equivalent to billions of atomic bombs, vaporizing forests and triggering firestorms across continents. The crater screamed guilt, the narrative seemed tidy, and for a long time, case closed. But that story is too neat. Beneath India, a far subtler, far deadlier killer had been at work long before the asteroid arrived. The Deccan traps, a volcanic system stretching thousands of kilometers, had been slowly poisoning the atmosphere, oceans, and soil for hundreds of thousands of years. Unlike a flash-killing asteroid, the traps were methodical, invisible, relentless. Dinosaurs couldn't sense it. Survival became a game of timing, adaptability, and luck, not strength or size. The asteroid is dramatic, cinematic, and terrifying. 10 kilometers of rock hurtled toward Earth at tens of kilometers per second. On impact, firestorms ignited distant forests, shockwaves circled the planet, and clouds of dust plunged the world into darkness. It's a spectacular image, a cosmic hammer smashing life with precision. But simplicity is misleading. By the time the asteroid arrived, ecosystems were already on life support. Food chains had been collapsing for centuries, plankton populations dwindled, and acid rain poisoned rivers. The asteroid delivered the coup de grace, yes, but the patient, invisible killer beneath India had already been orchestrating a slow-motion massacre. Survival wasn't about the spectacular strike. It was about enduring the invisible pressures long before the finale. 66 million years ago, Earth was alive in ways that boggle the imagination. Forests stretched to the poles, and jungles sprawled across continents. Rivers teemed with monsters, long-necked sauropods drinking from lakes, predatory theropods stalking unsuspecting prey, and armored ankylosaurs shuffling through ferns. In the skies, pterosaurs with wingspans rivaling small airplanes glided gracefully. Oceans were filled with marine reptiles larger than school buses, hunting fish and smaller predators with relentless efficiency. Life was abundant, bold, and interconnected. Yet subtle shifts, temperature changes, increasing acidity, and shifting atmospheric chemistry were already stressing ecosystems. Small, adaptable species could survive microclimate changes, but massive predators and herbivores, despite their dominance, were vulnerable to invisible threats. Survival required more than size. It required flexibility, timing, and luck. India, at the time a continent-sized tropical island, was lush and vibrant, filled with dense rainforests and strange creatures. Beneath the surface, however, a monster stirred. The Deccan traps began releasing millions of tons of carbon dioxide and sulfur dioxide every year, slowly altering the global climate. Oceans warmed, acidified, and became less hospitable for marine life. Birds, small mammals, and tiny reptiles adapted or fled, but the largest dinosaurs were unprepared for a slow, global-scale environmental collapse. This invisible, patient apocalypse moved like a shadow, creeping into every ecosystem, affecting food, water, and shelter without notice. For hundreds of thousands of years, volcanic gases quietly altered life on Earth. Acid rain fell across landscapes, rivers carried toxic runoff, and the oceans absorbed carbon dioxide, becoming deadly for plankton. Without plankton, the foundation of the marine food chain crumbled and predators starved. On land, herbivores found plants contaminated with toxins, while predators followed their prey into poisoned territories. Even giant predators like Tyrannosaurus could not hunt safely. Some may have died slowly, weakened by toxins in their prey or suffocated under ash-laden skies. Survival had become a game of chemical warfare between life and the planet itself. Around 300,000 years before the asteroid, the traps escalated. Rivers of molten rock stretched for kilometers, forests ignited, and volcanic ash darkened skies. Dinosaurs fled, yet their paths were blocked by lava flows, flooded rivers, and collapsing habitats. Predators lost prey, herbivores lost food. Juveniles perished first, adults followed. Local ecosystems were wiped out entirely. Even small, adaptable species faced challenges, forced to migrate or burrow into ash-choked ground. The Earth was reshaping itself into a planetary-scale trap, and life had nowhere safe to hide. Initially, the devastation seemed regional, but the effects were global. Sulfur and ash traveled thousands of kilometers on winds, subtly poisoning distant ecosystems. Ocean currents shifted, marine populations declined, and weather patterns became erratic. Predators found food scarce, prey populations collapsed, and disease spread faster than ever. The slow-motion massacre had reached the entire planet, and survival required ingenuity, timing, and extreme luck. Sulfur dioxide initially cooled parts of the Earth, while CO2 heated others, creating chaotic climate swings. Hypercanes, cyclones tens of kilometers wide, with winds exceeding 800 kilometers per hour, tore across continents, devastating forests and coastlines. Rivers flooded, ash rained from the sky, and forests died from drought and chemical poisoning. Even if a dinosaur escaped lava, acid rain, and toxic gases, survival still depended on navigating a world where every storm could kill. Life had never faced conditions like this, and adaptability became the ultimate currency. Mercury-laden clouds, hydrochloric acid rain, lava flows, wildfires, earthquakes, and tsunamis combined to create a perfect storm of destruction. Predators starved as prey vanished. Herbivores starved from poisoned plants. Juveniles died first, adults followed. Dinosaurs weren't wiped out in a single day. They suffered for decades, centuries, even millennia. Death came slowly, invisibly, and in waves. The Earth itself had become a serial killer, executing life with patience and precision unmatched by any asteroid. 50,000 years before the asteroid impact, the traps erupted at maximum intensity. Tens of trillions of tons of lava poured from the crust. Earthquakes shook continents, tsunamis reshaped coastlines, and firestorms engulfed landscapes. Dinosaur herds fragmented, juveniles died, predators starved. Survival became a lottery of microclimates, burrows, and chance. Even species that had thrived for millions of years found themselves unprepared for a world gone mad. Then the asteroid arrived. 10 kilometers of cosmic rock slammed into the planet, unleashing energy equivalent to billions of atomic bombs. Firestorms ignited distant continents, shockwaves traveled globally, and tsunamis destroyed coastlines. The asteroid didn't start the extinction, it merely delivered the final, dramatic punctuation. Species already weakened by centuries of volcanic apocalypse were finally finished. Life had been on the edge, and the asteroid shoved it over. Despite the chaos, a few species survived. Birds, small mammals, and hardy reptiles found niches, burrowed, migrated, or exploited microclimates. Survival depended on flexibility, size, reproductive rate, and adaptability. Dinosaurs, for all their dominance, could not survive environmental pressures that acted over centuries. Small species persisted, a testament to resilience in a world of relentless geological and environmental forces. Even after the asteroid, the traps continued erupting for hundreds of thousands of years. Ecosystems slowly recovered, but life was forever changed. Forests regrew, oceans stabilized, and new species evolved to occupy niches left vacant by extinct giants. Recovery was slow, but the planet eventually stabilized. Life, as it always does, persisted. Asteroid or traps? Both. Fossil evidence overlaps. Volcanic activity matches extinction pulses. Impacts deliver final devastation. The Earth itself is a serial killer. The Deccan traps weren't unique. The Siberian traps caused the Permian extinction, wiping out 95% of species. Patterns repeat. Dominance doesn't guarantee survival. Life is fragile when confronted with planetary-scale threats. Extinction is not random. Cascading failures, heat, acidification, food scarcity, can wipe out entire ecosystems. Adaptation, flexibility, and timing determine survival. Dinosaurs illustrate how even dominant species can fail. Humans, too, face fragility when confronted with forces operating on geological timescales. Survival is about reading patterns, observing, and adapting before it's too late. Imagine storms 3 times stronger than the deadliest hurricane ever recorded. Winds ripped tens of kilometers into the stratosphere. Forests were shredded. Firestorms spread. Acid rain fell continuously. Survival required extraordinary luck, mobility, and knowledge of safe niches. Few species could withstand the fury, and even the largest predators were vulnerable. Species that survived initial eruptions often died from starvation, disease, or exposure. Predators starved when prey vanished. Herds broke apart. Juveniles died first. Survival was a delicate balance, and even the slightest misstep could mean extinction. The fossil record preserves these lessons. Adaptability, mobility, and flexibility were the currencies of survival. No species is invincible. Dinosaurs ruled for 150 million years, yet the Earth's forces wiped most of them out in geological seconds. Humans may dominate now, but geological and climatic threats dwarf our technology and lifespan. Understanding Earth's patterns is essential, not just for knowledge, but for survival. Mass extinctions repeat. The Deccan traps, Siberian traps, and Central Atlantic magmatic province all show the same pattern. Prolonged volcanic activity leading to climate chaos and species collapse. Dinosaurs were victims, but Earth has repeatedly tested life. Observing these patterns teaches lessons about resilience, adaptation, and the fragility of ecosystems. Birds survived. Small mammals survived. Tiny adaptations made the difference between extinction and survival. Survival isn't about dominance. It's about adaptability, flexibility, and exploiting niches. Nature teaches through extremes, and the fossil record preserves these lessons for us to study and apply. Humans like to think we're invincible. Technology shields us from storms and earthquakes. Yet geological forces operate on timescales that dwarf our lives. A TRAPS-level eruption today could devastate infrastructure, food systems, and climate. Awareness, observation, and preparation are our defenses. Fragility is universal. Adaptation is essential. Even in a world with planetary killers, life continues. Kiwi co-creates, robot building, and experiments mirror exploration and problem-solving on a microscale. Curiosity is a survival trait, just like in the past. Life adapts, persists, and thrives, even in the face of overwhelming forces. By studying past extinctions, we learn about resilience, survival, and adaptation. Life has faced serial killers before: volcanoes, asteroids, climate shifts, and yet it endures. Observing these patterns reminds us that survival is not guaranteed, but possible with insight, flexibility, and courage. So, who killed the dinosaurs? The asteroid? The Deccan traps? Both? Science still debates the evidence. What's clear is that life on Earth is fragile, beautiful, and resilient. The Earth can be patient, invisible, and lethal, but it also allows persistence and adaptation. That's the ultimate lesson. Survival is both fragile and miraculous.